Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Ms. Stella or Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. Thank you for joining us today. So if you're taking Math 1314, you're going to stay in this room. If you're in 1324, they have placed a link that you can click to go on to the other session. And so I see a question in the chat first, so I'm going to address that question. And the question says, how do we enter, how are we supposed to type in our answers for functions? So it really depends on the problem on WebAssign. So sometimes, for example, the computer might already have the function. They might already have something like this, right? And so they just want you to enter the answer, which let's say I put it in the underline. Or if you're entering an equation, you might need to enter the entire thing, but you have to be careful on what is already given. So sometimes they might already give you this part. If you remember which question you're working on, then we'll look it up in a little bit. That way we can actually address that specific question. So if you do have that question, just type it in the chat and we'll look it up, and then that way we can address it for you. Okay, so so today we're going to talk about chapter 2 problems. Okay, so let me go ahead and go on to the next slide. And so when you start working with chapter 2, so for those of you taking a 10-week class or an 8-week class, you will start looking at this next week. So this is actually a good preview for you. If you are taking a 5-week class, then you already been working with this during this week. So a quadratic equation, we know it's going to be quadratic if the highest exponent of their variable x is a 2. If you have the highest exponent is a 2, then that means that this equation or this function is going to be quadratic, okay? And there's different forms, so we're going to look at those forms here in a second. So the first one here is your general form, and then the second one here is your standard form, which we'll look a little bit closer. Okay, so a quadratic function, as I mentioned earlier, the highest exponent of x is going to be a 2. That's how you know it's quadratic. And if you graph it, it's going to be a parabola that opens up, or it could also open down. And the number in front of the x squared is going to determine whether your parabola is going to open up or if it's going to open down. Okay. In chapter 1, you looked at the parent function, which was your x squared. So here we have our general form, and then this is your standard form. Okay. So the difference is just how it's written. And then if the number in front of x squared is positive, it's going to open up. If it's negative, it's going to open down. And so let's look at some more features. So here, this is where I'm mentioning. The lowest part of the parabola here, we call the vertex. And the vertex we can find using this formula here. Or you can also find the vertex using the standard form of the function. In this case, the vertex is h. So it's the opposite of what we see in here. So h and k. Okay. So if it opens down, we say that the graph has a maximum point. If it opens down, if it opens up, we say that it has a minimum point. These parabolas also have an axis of symmetry. which is basically a line that cuts the parabola in half. And as you can see here, it's represented with a dotted line. And the axis of symmetry is always going to be the x-coordinate of your vertex. So in this case, negative b divided by 2a. Okay? And so let's look at going from one form to another. So in the next examples, we're going to take a function that looks like this, and we're going to write it like this. And the reason we want to do that is because when it's in standard form, it's easier for us to identify the vertex, and then we can go ahead and also use transformations to graph the parabola. So if we have this function, f of x equals 4x squared plus 8x plus 16, your clue words here you're going to be asked to do is to write in standard form. So if you see standard form, then we're going to write it in this form over here. Let me go back. It's going to have to look like this second one. Okay. In order to do that, your first step is to look at the coefficient. Coefficient is the number in front of the x squared. So we're going to look at the coefficient of x squared, and we want to make sure that it's a 1. Okay. If it's not a 1, then we're going to factor out that number. So in this example, the number in front of x squared is a 4, and we need it to be a 1. So what that means is we're going to go ahead and factor out the 4. And in order to do that, I always like to put parentheses around the two terms that have an x involved. So for my 4x squared and my 8x. So from these two terms, we're going to factor out a 4. So what do we mean by factor out? If I was to factor out my 4 here, 4 times x squared is going to give me 4x squared. And 4 times 8/4 is going to give me my 8x. So essentially what you're doing is you're dividing each of these terms by this first number. So 4 divided by 4 is 1. 8 divided by 4 is going to be 2. But then since we did that by factoring out the 4. Okay. Once you do that, if we simplify here, 8 divided by 4 is 2x. So that's going to be your first step. Okay. The second step is going to be to take the number inside, the number in front of x, which we call our b, and we're going to take this number and we're going to take half of it. So 2 divided by 2 is equal to 1. And whatever answer you get here, we're going to square it. So 1 squared is going to be 1. Okay. So this number that we just got, we're going to add into this parentheses. But in order to add it, we're also going to subtract it. So notice here, I added my 1, but I'm also subtracting my 1. And if I do that, essentially I'm just adding a 0, right? So plus 1 and minus 1 is just 0. So the only reason we do that is so that we can manipulate our function to look like a standard form, okay? But essentially we're adding 0 in here. So let me repeat this step here. So after you take half of your b, which was 1, then you square it so you get 1. So 1, and you subtract. So you add the 1, you subtract the 1. Now what we're going to do is we're going to factor out that negative 1. We want to bring it outside. So if I want to bring this negative 1 outside, that's okay. But since I have a number outside of the parentheses, I have to multiply it by that number. So here I get 4 times negative 1 gives me a negative 4. So this negative 4, we're going to add it since we brought it outside. We're going to add it on the outside. So 4 times negative 1 is negative 4. So I'm just going to place it out here. And so now I have 4 parentheses x squared plus 2x plus 1 plus 16 minus 4. So it might sound silly that we put it in the parentheses and we took it out. But the reason for that is because now what's left inside is a perfect square. So x squared plus 2x plus 1, we can factor that, and that's going to be x plus 1 times x plus 1. So if we multiply x plus 1 times x plus 1, we get this information here. Okay, so why is that important again? Since I have 2 of them, right, I have 2 of these, then I can just rewrite it as 4 times x plus 1 squared, because I had 2 of these. And then 16 minus 4 is going to be 12. So now my equation is in standard form. And so I can actually get my vertex from here, which is your h and k, which is the number in here and in here. So from the parentheses, we take the opposite value. So instead of a plus 1, we would have a negative 1. And then we have our plus 12. And that's going to be your vertex. Okay, so Patricia or somebody, can everybody see my screen, or is it just Miss Steele that can't see my screen? Okay, so
I had to log out and log back in because the screen went away.
Okay, so try doing that, Miss Steele. Try to log out and then come back in. All right, cool. So now let's try another one. So with these, it takes a little bit of practice. So we'll go ahead and try a couple of more. Okay, so here we have f of x equals x squared plus 2x plus 1. Your first step is to make sure that the number in front of x squared is a 1. So do we have a 1? Yes, so that's great. Okay, so we don't have to factor out anything, and we just go on to step 2. Okay, so there's no number to factor out. But notice that I still went ahead and I put parentheses here and left a space because we're going to be adding something and subtracting something. Okay, so now that we have no number to factor, we look at our b, which is the number 2, and we go to step 2. And step 2 says to take half of this number. So this is my 2. So half of 2 is 1. And then we're going to square it. So 1 squared is 1. So once we do that, we go to step 3. We're going to add plus 1 and subtract minus 1. Okay, so now we're ready to remove this negative 1. We're going to bring it outside. And so let me just draw something here really quick. Get my pencil. So remember, we're going to take this negative 1, bring it out here, and we're multiplying it times the number out here, which is just 1. So 1 times negative 1 is just going to be your negative 1. Okay. So now, let me just, okay. All right, so if we simplify, the x squared plus 2x plus 1, again, it factors out as x plus 1, and plus 1 minus 1 is 0. So we end up with x plus 1 squared. So if we try to identify our vertex, we get the opposite of the parentheses. So that's going to be a negative 1. But then there's no k here. So your k is actually just going to be 0. The axis of symmetry, remember, is your x coordinate, which is the same as your x in the vertex, which is going to be negative 1. So let me see if I have another one. Yes, we have another one. So let's try one more time. So here, first step is to make sure that we don't have a number in front of the x squared. In this case, we do. So we're going to have to factor out that 2. Okay, so the best way to think of this is you're really dividing 2 divided by 2 and 8 divided by 2. But if we're doing that, that means that we're factoring out the 2. So we're going to write the 2 on the outside of the parentheses. And so I have my 2 out here. So 2 divided by 2 is 1. 8 divided by 2 is 4. Okay, so that's how we have it set up. So next, we're going to take the number in front of x, which is our b, and we want to take half of it. So 4 divided by 2 is 2. And then we're going to take that result and we're going to square it. So we get 2 squared, which is 4. So we can add and subtract the 4 into the parentheses. And that was, I guess we're on step 3, going into step 3. And now that we have that 4 minus 4 in there, we want to get rid of that negative 4. So we're going to bring it outside. So I'm going to bring the -4 out here. But in order for me to do that, I need to multiply it by what number? What do you guys think? Should I multiply it by 7 or by 2? So let's see. Okay, so we're going to multiply it. We bring it down. We're going to multiply it times the number in front of the parentheses. And so we get 2 times -4 is -8. Okay, so now let's simplify. So your x squared plus 4x plus 4 is going to be x plus 2 times x plus 2. So I do have a little shortcut here, especially if you struggle with factoring. Okay, so if you remember back in this step over here, when we had this number 4, we took half of it, and that half was 2. 4 divided by 2 was 2. Whenever you take half of this number, that's the number that's actually going to go here in your perfect square. So we have a half of 4 was 2. So we have the 2 and we have a 2. And so now we can simplify. -8 plus 7 is -1. And x plus 2 times x plus 2 is x plus 2 squared. And now we can get our vertex out of here. So my vertex is going to be, let me close the door. What is our vertex going to be? So our vertex, if we look at the parentheses, we have a +2. And so we take the opposite of that number. So we get a -2. Oops. Let me go back. Oh, it's right here. So we get a -2. And then we have our k, which is -1. Our axis of symmetry is going to be x equals -2, which is that x coordinate. Okay. So this is what we call completing the square. And it helps us to write our function in standard form. So when you're working on WebAssign, some of the problems are going to ask you to write in standard form. And so this is what they're looking for right here. Okay. And let me see. We can do one more. So we have 5x squared plus 15x. We're going to factor out of 5. Okay, so to factor out of 5, we write the 5 outside. And I'm dividing 5 by 5 is 1. 15 divided by 5 is 3. Okay. Now we're going to take half of 3. So half of 3 is 3 halves. And we're going to square it. So 3 halves squared is 3 times 3 is 9. 2 times 2 is 4. So we get 9/4. Okay. So we add the 9/4 and we subtract the 9/4. And then we're excited because we have fractions, right? So this is where your shortcut will come into play. So now I want to get rid of this 9/4, this -9/4. And so I'm going to bring it outside. And in order for me to do that, I'm going to bring it outside. So I have it here, -9/4. But since I have a 5 in the front, I have to multiply by 5. So -9 times 5 is 45. And then we have our 4. So where I get the -45/4. Okay. So let me repeat that again. So we bring out the -9/4, but since we have a 5, we have to multiply it by 5. And that's how I get this term. So let's simplify some more. In order for us to factor this, then we're going to have x and x, which is x squared. And then for our b term here, remember what I mentioned earlier, this number is always going to be the half of the 3 here. So since we had 3, we took half of it. That's 3 halves. So we have 3 halves and 3 halves. And then to simplify our fractions over here, in order for us to subtract, we need a common denominator of 4. So in order for this 5 to have a denominator of 4, I'm going to multiply 5 times 4 is 20. And then I'll have my 4 in the bottom since I have 4 times 1. And -20 minus 45 is -65/4. And then I have my 2 terms, so I can write them as x plus 3 halves squared. And then we have our 5. So our vertex is -3 halves. and negative 65/4. Axis of symmetry is your x-coordinate, which is negative 3/2. Okay, so again, when you're ready to get your perfect square here, it comes back to the half of this term. That's what's going to be in this place. Okay, any questions there? All right, so let's talk a little bit about the graph. So it says write the standard form of the quadratic function whose graph is the parabola shown. Okay, so I always like to write down some keywords. So standard form, they're talking about standard form. So I'm going to write down my standard form right here. They also give me a vertex, so I'm going to write down my HK here. And in order to write this standard form, what you need is the vertex and at least one additional point. Okay. And so what we're going to do is, so in this example, our vertex is -1, -1, and we need one additional point. So you want to pick a point that you know what it is. So in other words, you don't want to pick this point here because we don't really know what this number is, right? We can estimate it, but I know what this number is. This one is 0, 0. So I'm going to use that as my additional point. And now we're going to plug in this information. So remember that f of x is the same as y. So in my additional point, my y value is 0. I don't know what a is, so I'm going to put a. My x in my additional point is 0, so I'm going to write down 0 minus h. My h is -1. And then my k is -1. Okay. So if we simplify, what we're going to do is solve for a. Negative negative is +1. And if we square it, we get a 1. So a times 1 is a 1. And then my -1 here, I'm going to bring it to the left side. So I'm going to add 1. And I'm going to add 1. So I get 1 equals a 1. So that means that my a is equal to 1. So since they want me to write it in standard form, I just write my formula here. So I have 1 x minus h, which was -1, squared, and then my k is -1. Simplify, negative negative is positive. So that's going to be my standard form. Okay. So I believe I have a couple of more. So let's check this one out. So this one doesn't give you the graph, but it gives you the information that you need, right? It has the vertex and it has one point. Okay. So let's go ahead and work it out. So here's my standard form. Notice this is my h, that's my k, this is my x, and that's my y. I'm going to substitute those values into the formula here. So my y is 3. I don't know a. My x is 0. Minus h, which is -3. And k is -15. Let's simplify. Negative negative is +3. And then we're going to square it. So 3 squared is 9. And then 15 here, -15, I'm going to add 15 on both sides. So -15 plus 15 is 0. And 3 plus 15 is 18. Divide by 9. So I get a is equal to 2. So now I can replace it in here. So I have my a is 2, x minus my h, which is -3, and negative negative is positive. So this is my standard form. Okay. All right. So again, whether you're given a graph or if you're just given the points, the form is the same, or the strategy is the same. So now we've talked about the vertex. Now we want to find these points right here. And chapter 2 plays a big role in finding these points right here that I'm highlighting. And we call these points the x-intercepts, the zeros, the roots, or solutions. So if you have a problem that says find the solutions, they're looking for that point. Find the roots, it's the same point. Find the zeros, same point. Find the x-intercept, same point. It's where the graph crosses the x-axis. Okay. And in order to find these points, notice that the y value is always 0. So like this point here is 2, 0. This one's -2, 0. And so that's going to be the key to finding those points, is that y is equal to 0 for these points. How do we solve these points? There's different ways you can do it. These are just a few here. So square root property is a method, but it can always be used. So it depends on how the problem is set up. Factoring is one way, but it can't always be used. It depends on the problem. Quadratic formula, you can always use it, okay? And so it's just gonna matter on what you feel more comfortable with and what is given. So as a short review here, the square root property, normally you can use it if you don't have an x term, so you only have an x squared. And to do that, we will let the f of x, which is our y, equal 0. I'm going to add 4 on both sides, so I get 4 equals x squared. In order to get rid of my power of 2 here, I can take the square root on both sides. So the square root of x squared is x. The square root of 4 is plus or minus 2. So that means that we have x equals 2 and x equals negative 2 as our solutions. More importantly, we want to make the connection that this are the points on the graph. This 2 and negative 2. So this graph is going to go something like this. Okay. All right, so let's look at the one next to it. If we're trying to solve, first step, you let f of x equal 0. And here we can use the square root property, but first we need to isolate whatever is being squared. In other words, this 27 here needs to be gone. So we're going to add 27 on both sides, so plus 27, and negative 27 is 0, and 0 plus 27, 27. The 3 here is not being squared, so we need to get rid of it as well. So I'm going to divide by 3 on both sides. So divide this by 3, and 27 divided by 3 is 9. And now notice that x minus 4 is the only thing that's being squared. So you can take the square root of all of that, and we can take the square root on both sides. So the square root and the square is going to become 1. So we get x minus 4, and the square root of 9 is plus or minus 3. So now we can add 4 on both sides. So we get x equals 4 plus or minus 3. And we can write it as x equals 4 plus 3, which is 7, and x equals 4 minus 3, which is 1. So these are our two zeros. Okay. So these are two examples using the quadratic function. The square root property. Now for factoring, we do the same thing. We let y equal 0. So here's my 0. And then you want to see if you can factor this. Okay. And so in the chat, they're putting some links and stuff in there, but one of the links is a link to our YouTube channel. And in that YouTube channel, if you struggle with factoring, if you go through the videos, you'll find a video that just deals with factoring from the spring semester. So I encourage you to take a look at it because it goes through tips on how to factor. Okay. So here we have a negative 6. So 3 times 2 will give us a 6, negative 6. And then since x is negative, we'll make the bigger number negative. And so we have x minus 3 times x plus 2 equals 0. Once we have our two factors, we can set each factor equal to 0. So x minus 3 is equal to 0, x plus 2 is equal to 0. Add 3 on both sides, so we get x equals 3. And subtract 2 on both sides, so we get x equals negative 2. So factoring, when I'm doing the problems, I like to try to factor first. But if I can't factor it in the first minute, then I move on to a different method because it might not be factorable. So factoring doesn't always work. And when it doesn't always work, then that's when you want to use the quadratic formula. So this is your quadratic formula here. And the way that works is that the number in front of x squared is a, the number in front of x is b, and then your constant is the number without the variable. So if we plug it into the formula, we have negative b, which is negative 2. So we have minus negative b, negative 2, plus or minus the square root of b. Again, our b is negative 2 squared, minus 4 times a. A is the number in front of x squared, which is 1. And c is our constant, negative 8. And then we're dividing by 2 times a, which is 1. So if we simplify, negative 2 squared is 4. Negative 4 times 1 times negative 8 is positive 32. 4 plus 32 is 36. And then we have this right here, right? So the square root of 36 is 6. So 2 divided by 2 is 1. 6 divided by 2 is 3. And we can write our answer as x equals 1 plus 3, which is 4. Or x equals 1 minus 3, which is negative 2. Okay, so these are just different options that you can use. So that was kind of an overview of 2.1, right? So 2.2, what is the polynomial? Polynomial functions are continuous graphs like this one. This is continuous. This one is not continuous because when you're trying to draw it, you have to pick up your pencil to draw the second part, okay? Polynomial functions are smooth with rounded turns. So like this is really smooth and the turns here are rounded. If there's sharp corners, then those are not polynomial functions. One section 2.2, they want to know the behavior of the graph. Okay. So what I like to tell my students is you can try to memorize all the rules they give you in the textbook, or you can just use these 4 graphs. With these 4 graphs, you should be able to figure out the behavior. Okay. So this first graph is the x squared, and it's a parabola. It opens up. The second one is a negative x squared, and the parabola opens down, right? And then the next parent function is x cubed, and this is a shape for that. And then the negative x cubed reflects, so it looks like this. Okay, so how does this work? So in order to determine the end behavior, you're going to look at the degree. If the degree is even, like it is here, and if the coefficient, the number in front of x squared, is positive, then the behavior on the left side is rising up, and on the right side is rising up. So we would write the end behavior rises to the right and it rises to the left. If the degree is even, like in this case, but the coefficient is -1, then it makes the graph fall down or it open down. So if you look to the far right, it falls, it's going down. And if you look to the far left, it's also falling down. Okay, so we say the behavior falls right, falls left. If the degree is odd and the coefficient is positive, then the behavior to the right is that it's rising to the right, but it's falling to the left. And if the degree is odd with a negative coefficient, then the behavior is that it's rising to the left, but it's falling to the right. Okay. So if you ever forget the rules, but you remember these 4 graphs, then you can see it right. So let's try some examples. Okay. So I have this example. So one, you need to know the degree. The degree is your exponent, the highest exponent that you see here. In this case, 8. Okay. And so you want to ask yourself, is 8 an even degree or is it an odd degree? Okay. And so we know it's even. Since it's even, that means that you're looking at this graph or you're looking at this graph. Then we're going to look at the number in front of it, which is 3. And you decide, is 3 positive or is it negative? So 3 is positive. And so the behavior is going to be like this first one, x squared. So what we would write is that the behavior, let me keep going, it's going to be like this. So we would write that the graph will rise to the right and it's going to rise to the left. So rises right, rises left. Okay, let's try another one. So here we have a 3 and a 2. So we want to look at the highest one, which is 3. 3 is odd, so that means we're working with graph number 3 or graph number 4. The number in front of it is negative, so that means that my behavior is going to be like this one here. So my answer that I would write is that the graph rises left, right? It rises left, but it falls to the right. Let's try another one. Okay, so here we have 6, 5, and 8. So be careful here because if you're looking at 6, then your problem might be incorrect because the degree of this polynomial is the highest, which is going to be your 8. Okay. So since 8 is even, that means we're looking at example 1 or example 2. It's negative. That means that the graph is going to open down. So the behavior is going to be like this one. So we would write that the graph falls to the left and it falls to the right. Okay. The next one. So here we have x cubed, 9x squared, and 8. So if you have a number or if you have a problem that's not multiplied out, then you want to make sure that you multiply it out. So you have negative 2 times x cubed is going to be negative 2x cubed. So my degree is still odd, which is 3. So it's going to act like the second, like the third or fourth. And the coefficient in front of it is a negative 2. So my behavior is going to be like the last graph. So I can write that the graph rises to the left and falls to the right. Okay, so that's your end behavior. The other thing in this section is, how do we know that our graph is going to come up and that it's going to touch this point and turn back? Or how do we know that it's going to go through the point and continue going up? Okay, so if you notice here, it goes through the point. Here it touches and turns. And then here it goes through the point. Here it goes through the point, and through the point. So our goal is, how do we know that? Okay. So if we look at these zeros, they play up a big role, right? Let's look at this example. So at negative 2, notice my zeros. I have x equals negative 2 and x equals negative 2. That was repeated twice, right? And it touched here. So that might be a clue. Let's check this one. At x equals 0, we have 0 and we have 0. So that was also repeated twice and it touched and then it turned. And so it turns out that if a 0 is repeated an even number of times, then it's going to touch and turn. But if a 0 is repeated an odd number of times, then that's when it's just going to cross like this. Okay. So if I had x equals 4, x equals 4, and x equals 4, the graph would still just cross. Okay, so if it repeats an even number of times, then it touches and it turns. And I believe this is what I just said, right? But the reason I have these two graphs here is because there's so many rows, but if you remember these two basic parent functions, then for x squared, you notice it's touching and turning. If you were to solve for your zeros, you can see that you get a 0 that is repeated twice, right? And if you solve for the zeros here, you get a 0 that's repeated 3 times and not number of times. And in this case, it comes and it crosses through that point. And in this case, it just touches and turns. So if you forget, you can always come back to these basic two graphs, okay? So your next task is to find all the real zeros of this polynomial, okay? So the first thing you want to do, since you want to find the zeros, remember another name for zeros is x-intercepts, which means to let y equal 0. That's your first step. So here y is equal to 0. I'm going to check if factoring works. So let's check if that works. It does, right? So x minus 1 times x minus 1. We can set each factor equal to 0 and solve for x. So x is equal to 1 and x is equal to 1. So my zeros are x equals 1, but notice I have two zeros that are the same. So that means they're repeated. So when they're repeated, it wants to know the multiplicity. When they ask you for multiplicity, they're just asking you how many times does that 0 appear. So here, how many times does x equals 1 appear? It appears twice. So the multiplicity of x equals 1 is 2 because it appears twice. Since it appears an even number of times, when it gets to that 1, it touches and then it turns. Okay. Oh, let's try this one. So I want to find the zeros. My first step is let f of x equal 0 right here. And notice that all the terms have some t's in common. They actually all have at least 2 t's, right? So we can factor out a t squared. So if I have t to the 4th divided by t squared, we get t squared. T cubed divided by t squared, we get a negative t. And negative 30t squared divided by t squared is negative 30. And then we can try to factor some more. So t squared minus t minus 30, I can get two factors that give me 30 is 6 times 5. And if I add or subtract, I'll get a negative 1. And so my sign here, I need it to be, the 6 needs to be negative because it's the bigger number. And then we have our 5. So we can set each term equal to 0. 0 equals t squared, 0 equals t minus 6, 0 equals t plus 5, solve for t. And so we get, let's look at this one. If I subtract 5, I get t equals negative 5. And this one will give me t equals 6. And t squared equals 0 is t 0. Okay. So let me just talk about that really quick. Because this is a common mistake here that I see for the t squared equals 0. So some of you maybe said, okay, we can solve by taking the square root. And we get 0. Oops. And that's okay. But in this situation, t squared is equal to 0. We can also write it as t times t is equal to 0. So t is equal to 0 and t is equal to 0. The reason I write it this way is because since they want the multiplicity, notice that the 0 appears twice. Okay. So this power right here is telling you that this 0 is going to appear twice. If it had a 3, it would tell you that it's going to appear 3 times. So you want to make sure that you're careful with that multiplicity. So the 0 has multiplicity of 2. 6 has multiplicity of 1 because it only appears one time. And negative 5 has multiplicity of 1. And so at t equals 0, my graph is going to touch and turn. At t equals 6 and at t equals negative 5, the graph is going to cross right through it. Okay. And I have a picture here. So notice at t equals 0, it touches and turns. And then through 6 and negative 5, the graph just crosses. Okay. And so if you look at the behavior, this is even and it's positive. That's why right here, our behavior, and you can't really see it, so let me draw it really quick, is going up on the left side and it's going up on the right side. Okay. All right. So now we have sketched the graph of x cubed minus 3x squared. So let's try another one. So to graph this, we need to do some things. We need to identify the end behavior, find the zeros and the multiplicity, find the y-intercepts, and plot additional points. So the degree here is odd, and it's positive. So my behavior is that it's going to rise to the right and fall to the left. Okay, the zeros, we're going to let y equal 0. I have x squared in common, so I'm going to factor out x squared times x minus 3. So I get x squared equals 0 gives me x equals 0, and x minus 3 equals 0 gives me x equals 3. Since I have a 2 here, that means that x equals 0 is multiplicity 2. It appears twice. So that's going to touch and turn. And x equals 3 is odd, so that's just going to cross. And then we're going to find the y-intercept. To find the y-intercept, you let x equals 0. So if x is 0 here and x is 0 here, then we just get 0. So the y-intercept is at 0, 0. Okay, so your first step is to plot the zeros. So my 0 is x equals 0 and x equals 3. And then my y-intercept is the same as my x-intercept, so that's okay. And then I'm going to apply my end behavior. Okay. So my end behavior is that it rises to the right and it falls to the left. So now we don't know what's going to happen. Like, how do we connect the graph in between? And that's where the additional points play a key part. So I'm going to plot some points for 1 and 2. So if x is 1 and I plug it in here, we get 1 cubed minus 3 times 1 squared. So we get So there's a okay. So we get 1 squared. That should be 1 cubed. So that's going to be 1 minus 3 times 1. So we get -2. And if we do the same for 2, then we get 2 cubed minus 3 times 2 squared equals -4. And if you wanted to, you could also click 2.5, but that's going to be up to you on how many points you want to pick. So if I plot these additional points, then my graph will look something like this. Okay. And I have the real graph here in case you want to see it. Okay, so now synthetic division, complex numbers. Let me just close my door really quick.
No,
Mama, I'm not finished, okay?
not finished.
No, I'm almost finished, okay?
Okay, we're gonna go. Shh. We're going to go McDonald's.
Sure, but you need to be quiet. All right, so now for synthetic division, let me just skip through this here because I want to get to the long division and synthetic division. Okay, so if you want to divide something like this, then the first thing you want to do is make sure that all of these are in descending order. Okay, so they have to be in order. So you have cubed, you have squared, and then you have your x and your constant. And the same for your divisor. So they have to be in descending order. So what you want to do is look at the 20x cubed and ask yourself, can I divide by 4x? Okay. And so let me see if I wrote it here. I did. So 20x cubed divided by 4x gives me 5x squared. And so that's what's going to go on the top here. And then we're going to multiply. So 5x squared times 4x gives me 20x cubed. And 5x squared times 3 gives me -15x squared. And just like when we're dividing numbers, we're going to subtract this. Okay? So we're going to distribute the negative in here and the negative in here. Okay, so that's what happened here. So negative times this is -20x cubed. Negative times negative is +15x cubed. So if we add these, we get 20. So if we add these, we get 20x cubed minus 20x cubed is 0. -35x squared plus 15x squared is -20x squared. Bring down your next term, 23x. And now we repeat the same thing. So -20x squared cannot be divided by 4x. Okay. And it will give it a 5x, right? So -5x times 4x is -20x squared. -5x times -3 is +15x. Remember, you're going to distribute this negative, so negative will be positive. Negative and positive will be negative. And I wrote it over here. So negative is positive. Negative and positive is negative. So if we add, these will become 0. 23x minus 15x is 8x. Bring down the -6. And then we start the process again. So 8x divided by 4x is going to be a 2. So 2 times 4x is 8x. And 2 times -3 is -6. But remember, we have to subtract. So when you do that, it changes it to -8x and +6. So we get 0. Okay. So 0 is your remainder. And let me see if I have it here. So that's our remainder. This is your quotient, which is your answer, your divisor. And this stuff inside is your dividend. Okay. So when you write your answer, you're going to write it as your quotient plus remainder divided by your divisor. So this is your quotient. This is your dividend is equal to the quotient plus your remainder divided by the divisor. Okay, for synthetic division, that's what I like to use. I prefer synthetic division. What you do here is you take the coefficients. So in front of x cubed, I have an a, so I write down the a. In front of x squared, I have a b. In front of x, I have a c. In front of d, I write, in front of your d is your constant, d. These have to be in order as well, okay? If you're missing a term, you would use a 0. So like if I didn't have an x here, I would use a 0 in place of c. And then your divisor, x minus k, we're going to be dividing by that k. So, and then once you have it listed here, we bring down the first one. and then we multiply it times k. So k times a is ka. And then we're going to add it to b. And we keep going. So let me just give you an example with numbers, because it'll be easier to see. Okay, so here, what is k? So k is your -1. So we write +1 here. Okay, so k is your 1. Next, we list the coefficients. So we have a 1 in front of x squared, a 5 in front of x, and our 6. Next, we're going to take the 1 down. So we bring down the 1. And now we're going to multiply 1 times 1. 1 times 1 is 1, so we write it up here. And now we're going to add 5 plus 1, which is 6. And then we repeat the same thing. 1 times 6 is 6, so I write it here. And 6 plus 6 is 12. Okay. And then we're done. So your last number is your remainder. And then your dividend, if you notice, we started with an x squared, right? 5x plus 6. So for your quotient, you're going to go 1 degree less. Okay, so 1 degree less. So instead of x squared, this 1 is going to represent x. So here's my x. And this 6 would just be your constant, 6. And then you still write your remainder divided by the divisor. So I think I have one more in here. We have 4 minutes, so we can do it. So here we have the same problem, so let's set it up. So I'm going to use 8 as my divisor, or my k. I have my coefficients, 4, 36, 36, and -32. We're going to bring down the 4 times 8 is 32, plus 36 is 68. If we multiply again, 68 times 8 is 544, plus 36, 580 times 8 is 4,640, plus -32. So we get 4608. So this is our remainder. Now our quotient, since we started with x cubed, we're going to start with x squared. So we're going to have 4x squared, 68x, and 580. That's going to be your quotient here. Now, in later sections, if you get a remainder of 0, that is the best thing that could happen to us. Okay? Because that's going to tell you that that number is a 0. Okay? So let's try one more. Here, notice that in order for us to divide, we have to have it in the form x minus k. But here we have an x plus 7. Well, it's not a problem. We can just rewrite this as x minus -7. So our k is going to be -7. So really, it's the opposite of what you see here. If you see +7, you use -7. If you use a -6, you would use a +6. And then let's look at the coefficients. So we have a 3 for our x cubed, 21 for our x squared, -6, and -42. Bring down the 3. Bring down the 3. 7 times negative, or 3 times -7 is -21. If we add to the 21, we get 0 times 7 is 0, plus -6, -6, times -7, 42, and then we get 0. Okay. So my remainder is 0, my quotient. So this is going to be, instead of x cubed, we start with x squared. So we get 3x squared. There's no x, and then -6. So my quotient is 3x squared minus 6. Okay, so earlier I said that if you get 0, that's a good thing. And so the reason it's good is because it's telling us that at -7, here's -7, you have a 0. Okay, and now you can take the quotient, 3x squared minus 6, you can set it equal to 0 to find your other zeros. Okay, and in sections 2.5, you can see that happening there. So obviously, I'm not going to have time to finish this whole thing. So what I want to do is just highlight, if you guys can see my pointer here, right above is a square with an arrow pointing down. If you click on that, you'll be able to download the PowerPoint. And if we go through the PowerPoint, it goes step by step on how to do each of these problems all the way. It probably covers all of chapter 2. So I encourage you to look at it. If you don't want to just read a PowerPoint like this, then I highly recommend our YouTube channel. And you can go through the spring videos, and you can find videos, look them up by topics. And so you'll be able to see the topics. I want to put it in. Okay. So I'm going to pass it over to
Thank you, Ms. Truca, for your presentation. If you would like to download the copy of the presentation, you can go to the top right corner and click on the box with the arrow going down while the presentation is on the screen. We do want to remind you all about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey, and before you all leave, I want to share the TVE sessions that we will have next. One moment. Okay, there we go. So join us again next week at 1 p.m. for a presentation by IT on the new self-service banner, a platform to register and view your academic information. And at 3 p.m., we will be back with Happy Math Hour, where Math 1314 will cover exponential and logarithmic functions and properties of logarithms. And Math 1324 will cover simple and compound interest annuities and systems of equations. Thank you all for coming in today. We hope you all have a lovely weekend. If anybody has any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.